Let's do this. Here's a bigger diagram of what is going on. We're being asked to work out the sides of this octagon. And so if I can work out one side and times it by 8, then I can work out the perimeter. So I'm going to add on to my picture some key information. We're told we have two concentric circles. That means they have the same center. And this one has radius 1 and this one has radius 2. So if I connect up the points where the octagon meets the circle, it's actually quite hard to see, isn't it? It's going to maybe be here, okay, because this line is very thick. And then here. And then if I draw these in as well, what I've actually created is a kite. These two are the same length, and these two are the same length. This is length 1. If I do a dashed line going from the center to that point, this is going to be length 2. But I can not just draw one kite, I can actually draw 4 kites. So there's another one. Another one. And my 4th one. And these are symmetrical, so it must be that each of these angles is 90 degrees, just 360 divided by 4. So if I want to work out what this angle is, it's just going to be 90 divided by 2 because this has a line of symmetry down it, and this is 45 degrees. And now we're well on our way because we want to find this side here, and I have a triangle where I know two sides and I know the angle in between. So let me just kind of sketch it out over here. One thing that needs to be said is that this is not 90 degrees, okay? Because the line is not a tangent, it's kind of going into it and then coming out. So don't make that mistake. It's not an isosceles triangle. I'm going to try and make sure when I draw it that I make sure it doesn't look like 90. There we go, it's not bad. Now I know that this is 1, this is 2, this is 45 degrees. There's a quick way of dealing with this problem at this point to work out this missing length, and there's a slower way. The quick way requires you to know something called the cosine rule. So I'm going to go through it. It's basically assuming that you have seen the cosine rule before. If you haven't, then stick around and I'll show you the longer way. It's more complicated, but it will get you there. With the cosine rule, I'm going to label my sides. I'm going to label the missing side C, and this is going to be A, B, and this angle opposite is actually capital C. Let me make it a little bit bigger, capital C. And the cosine rule says that c squared is equal to a squared plus b squared, a bit like in Pythagoras' theorem for a 90-degree triangle. But because I don't have a 90-degree triangle, I need to minus 2ab cos c. And now I can just substitute in. So it's going to be 1 squared, which is just 1, plus 2 squared, which is 4, minus 2 times 1 times 2, cos 45 degrees. That is going to equal 5 minus 4 cos 45. Well, that's actually, see, that's something you have to know. It's 1 over root 2. So I get 5 minus 4 over root 2. I'm not going to go into any more detail on the cosine rule or learning exact trig values. That is one issue with this method. If you're not familiar with it or you don't know your trig values, it's going to be, it's going to be quite challenging. So we have c squared, and therefore c is going to equal the square root of 5. Okay, actually, sorry, before I do that, and you can see there's no, we're not dividing by any surds. So I just need to tidy that up, and I can do that by rationalizing the denominator. I can times top and bottom by root 2, which changes it to this. And this is just 2, so it's 5 minus 4 root 2 over 2, which simplifies to 5 minus 2 root 2. And then c is going to equal the square root of that. Now, sometimes it's actually possible to take the square roots of things like this and get something that's much simpler. But you see in the final answer, they've left it, in surds, and actually I can already see the answer. The answer is going to be E, because I've worked out what one missing side is, but I've got 8 of them, so I just need to times by 8. So we're done. I've used the cosine rule, I've used my knowledge of exact trig values, and then it's come out quite easily. Now let's imagine you've never seen the cosine rule before and you didn't know that cos 45. Well, don't despair, because we can actually still solve this problem. So this is going to be method 2. Actually going to make it a little bit bigger. Okay, method 2 involves splitting this non-right angled triangle up into 2 right angled triangles. This bottom one and this top one. In fact, this is how you prove the cosine rule to begin with, or one way of proving the cosine rule. What this does is give me 90 degrees here and another 45-degree angle here. Remember, I'm trying to work out this missing length. Well, now I have an isosceles right angled triangle. So this and this are going to be the same length. So why don't I call it x? Then x squared plus x squared is going to equal 1 squared, or 1. 2x squared is going to equal 1. X squared is going to equal a half. And therefore x is equal to 1 over root 2. I could also write it as root 2 over 2, but let me leave it like that for the moment. So I can cross this out now, 1 over root 2. That means that this length here is going to be 2 minus 1 over root 2. And this length is 1 over root 2. So I can now use Pythagoras' theorem again on this top triangle. Let me call this, what should I call it? Well, I called it C before, so let me call it C again. So C squared is going to equal 1 over root 2 squared plus 2 minus 1 over root 2. So the disadvantage of this method is that I'm having to square quite horrible surds, but I've not had to remember cos 45 or the cosine rule. This is going to give me a half. Right, this is a double bracket, remember. It's 2 minus 1 over root 2 times 2 minus 1 over root 2. So I'm going to get 4. Then I'm going to minus 2 times 1 over root 2, which is just going to be 2 over root 2. But then I get another one of those. So actually, let me write it in. And then I'm going to add minus 1 over root 2 times minus 1 over root 2, which is again a half, because I square the root 2. And that is going to give 5 minus 4 over root 2, which I can simplify times in top and bottom again by root 2. I'm going to get 4 root 2 over 2, so it's 5 minus 2 root 2. So I've managed to work out C in this different method, using this different method. And look, we get exactly the same as before. I just have to now square root it. And then the perimeter would be to multiply it by 8. So, really good method. Enjoyed that. I hope you did as well. Two different approaches, but we get this answer at the end of it. Hope you're happy with that. Well done.